this section, we are going to look at maximum and minimum values. So before we look at calculating, finding, and identifying maximum and minimum values, let's look at a few definitions so that we understand what maximum and minimum values are. So the first definition that we're looking at is absolute maximum. And the absolute maximum is the largest output of the domain. Remember, the output refers to the y value. The x value is the input, the y value is the output. So this could also be thought of as the biggest y value when you substitute in all of your x's or you check different x values of your equation, the biggest output, so the biggest y of the domain, so the biggest y of your function. Absolute minimum is just the reverse. It's the smallest output. And the absolute maximum and the absolute minimum are called the extreme values. They're the absolute largest, absolute smallest, so it's the extreme values. Then we can look at the local max and min. What that means is it's the maximum on an interval or it's the minimum on an interval. So the difference is instead of considering the entire domain, you're just considering a portion of the domain. So the local maximum is the maximum on an interval. And the local minimum is the minimum, so the min on an interval. It gets a little bit tricky because the local max and the local min, they include the absolute values for the absolute max and the absolute min as well. So I will show you what I mean with that in just a minute when we get down to some examples. And then the last definition we need is the endpoint. So when you're looking at the endpoint, that's the ends of the function. And an endpoint can be an absolute max or min, but it cannot be a local max or min. So the endpoints are the ends of the domain. And it can be an absolute max or min. But it cannot be a local max or min. So let me show you what I mean by this. So for number one, we are given two graphs here in part A and part B, and we have the labels for A through T. And what we're trying to do is figure out from the graph if each of these points are a absolute max, absolute min, local max, local min, or an endpoint. So we're trying to figure it out. And then it's also saying that if it's none of these, let's put neither so that we've got that written on as well. So let's look as we go through here. I like to start with the absolutes because then I know I've got those covered. So where is the highest point on here? So as we're looking across, right here at B, this looks like it's the highest y values. Now we don't have a y scale, but we can see that that looks like the highest part up the y scale. So right here at B, I'm going to label this as an absolute max. Now I need to find the absolute min. What looks like the lowest value? And I think it looks like right here at point D. There we go. Okay, so we got those. A is an endpoint. F is an endpoint. The endpoints cannot be an absolute max or min, but we're okay because we found our absolute max and min. Now what happens is we look for local max and mins, and the local max and mins are the highest or lowest points on a region. So like, for example, right here, this would be a local max. And it would be a local max because from D through F, that's the maximum. It's not the maximum on the entire domain, but it is a maximum on an interval. And in our case, that interval could span a good portion of our graph. So that would be a local max. Now we have to remember the absolute max and min can also be a local max and min. So we already labeled this one, so let's label it again. So it would be labeled as a local maximum and as the absolute maximum. This endpoint right here, we don't know what would happen over to the other side. So it cannot be a local max or a min because it's an endpoint. So this would be a neither. It is possible, and we'll see this in part B, for the endpoint to be a absolute max or min, but not a local max or min. So we have B labeled. Let's look at part C. Part C, this isn't a max or a min, so it's not going to be either. So we're just going to label it as a neither. Same thing right here with part R, it looks like. But S right here, that's going to be a local min because it's the minimum, and it's the minimum on this portion of our graph right here. Let's label that local min. Right, we got everything labeled for part A. Let's try part B. So let's start with our max and our mins. So the highest point to me looks like it's right here. So that's going to be our absolute max. And right here looks like the lowest point right here. So that's going to be our absolute min. Write that a little bit more clearly. And we've got our absolute max, we've got our absolute min. So let's see what else we can find. We know that this is an endpoint right here. Our absolute min this time is an endpoint. And that's okay. The absolutes can be endpoints. The locals cannot. So absolute endpoint, that's okay. Now let's see what else we can figure out in here. So there's some tricky things going on with this one. Let's take the ones that aren't too tricky, and then we'll come back to the ones that are extra tricky. So let's look at point R and point S. This looks like a min. It's not the absolute min, but it is a min. So this is going to be a local min. This looks like a max. It's not the absolute max, so it's going to be a local max. And don't forget, this can be a local max as well, because it's the absolute max, and that can be local as well. But this cannot be a local min because it's an endpoint. So it can only be an absolute min. Okay, we still have a couple that we haven't looked at here. Now this one is extra tricky. If you think about looking at your graph on this portion right here, we have this curve down to a straight line. If you think about looking right here, you have this straight line. So this is tricky because along that straight line, it's not increasing or decreasing. So it's a maximum and a minimum all at the same time. So as you're coming down here, you get to a local min. But then as you get over to point C, technically it's a maximum and a minimum because it hasn't changed at all. Technically it's both. It stayed consistent. So this one's super tricky. This right here at the same time is a local max and a local min because it's both the highest and the lowest value on that interval. And then right here in part D, same idea. That's a local min. There we go. I think we got them all labeled this time. Let's try another one. Use the graph to state the absolute and local maximum and minimum values of the function. All right, well, let's see what we can figure out here. So we need to figure out our absolute max. And let me move this over so I have a little bit more space. There we go. We need to figure out our absolute min. We need to figure out our local max, and there could be more than one of those. And we need to figure out our local min. And there could be more than one of those. All right, so let's look at our points on our graph. So it looks to me like right here is the highest. What is that? 1, 2, 3, 4 for the X. 1, 2, 3, 4 for the Y. So it looks like this point right here, 4, 4, is our highest. So our local max occurs when our X is 4. So when X is 4, we're at our local max. So if we want to state the local max and the local min, we can state it based on the X value. Let's try another one. Let's see, where's our absolute min? Where's the lowest point that we have on our graph? I think it's right here. So that was 4, 5, 6, 7. So this point right here would be 7, 0. It doesn't cross below the x-axis anywhere, so I think that's our lowest. So our absolute min will occur when x equals 7. Now our local max, we can have a couple different local maxes as we look through. Let's see what we've got here. This right here at 0, 3, that's an endpoint. So we can't use that as a local max. That would be a neither. We can't use that one. Let's see what else we've got. Well, we know the absolute max can also be a local max. So let's put x equals 4 on our list and keep looking. Here we go. Here's another one. 4, 5, that looks like 6. So that point right there looks like it is 6, 3. And that's the max on this piece right here. So x equals 4 and x equals 6. So 4 and 6 are both a local max. Let's try local mins. Well, I can't use 7 because 7 is an endpoint, and the endpoints cannot be a local max or min. They can be an absolute, but they can't be a local. So it looks like our local min would be right here, and that looks like our point 2, 1. So the local min would be x is 2, and right here looks like we have a min as well, and that looks like our point 5, 2. So 2 and 5 would be our local min. Let's try part B. So we need an absolute max. We need an absolute min. We need a local max. And we need a local min. All right, let's start at the top. Absolute max. Where's our absolute max? I think it's all the way up here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yep, 7, 5. So our absolute max, our highest y value, is going to occur when x is 7. So x equals 7 is our absolute max. Now, where's our absolute min? Where's our lowest value? That looks like it is right here. And that's when x is 1, y is 0. So our absolute min will occur when x is 1. Now we have some other things going on in here. So let's see if we can figure them out. This right here, what is that? Looks like the point 0, 2. This looks like a local max. Let me put that on my list. So x equals 0. There we go. I have a feeling we're going to have some more. So let's just keep going as we go through. Right here we've got one. So what is that? 1, 2, 3. 1, 2, 3, 4. So 3, 4. So when x is 3, it looks like we also have a local max. And we have another one right here. So this looks like 5 and 3. There we go. So it looks like we'll also have a local max when x is 5. So we have a lot of local maxes this time. So we have one right here at 0. We have one right here at 3. And we have one right here at 5. Now we cannot include this one at 7 because it is an endpoint, and only an absolute max or min can be an endpoint. So let's try our local mins. Well, it looks like this is an endpoint, so we can't use that one. 1 is our absolute min, so we can use that as a local min as well. This looks like 4, 2 for this point. That would be a local min because it's the minimum of this piece. And right here, looks like the last one. So that's when x is 6 and y is 1. All right, I think we've got them all. So we have a local max when x is 7. We have an absolute, we have an absolute max when x is 7. We have an absolute min when x is 1. That should say, here it is, 1 right there. We have an endpoint right here. We have an endpoint right here, so they can't be locals. We have a local max at 0, x being 3, x being 5, and we can't make that a local. And we have a local min at 1, 4, and 6. I think we got them all.